Hey guys, welcome back to another video. Today I have an incredible piece of vintage avionics to take apart. I'm not sure which aircraft this one was used on, but I have a second DME of this exact model that was used on the Brandif Boeing 727. I have discussed DME before, but in short it stands for Distance Measuring Equipment, and it tells pilots the distance between the aircraft and the airport. Okay, here's the front. You can see we have our typical Collins branding up here. We have a little transparent window here which reveals a little dial in there. Here's our handle. We also have a test button here too. This connector here is for the suppression signal, which connects to the aircraft suppression bus. Powerful transmitters on board an aircraft require connection to the suppression bus to keep transmitters from interfering with each other. This other connector outputs DME data from the receiver section of this unit for the use of other avionics equipment. This big connector here is the main antenna connector that goes to the antenna on the exterior of the aircraft. It both transmits and receives distance information from the ground-based stations using a frequency between 960 and 1215 MHz. Here we have our typical mounting brackets for mounting it into the avionics rack. Here's our information tag. You can see this one is model 860E-2. And it is 35.6 pounds, and we have quite a few modifications on this one. Alright, so here's the back of the unit. You can see here we have two multi-pin connectors, each of which have 32 pins. We also have some holes back here which help it line up in the avionics rack. Here's what it looks like on its side. You can see we have holes all over this to allow airflow. So here's our first look on the inside. As you can see, this is very densely packed with all kinds of cool stuff, and we will be taking a close look at everything in here in this video. The first piece I want to take a look at is this piece here, which is called the distance mechanism. There are 4 screws holding it on. I believe this device here is what actually counts the miles. You can see here the little dial that's underneath this little indicator plastic piece here. On the bottom here we have a pretty big D-sub connector. You can see this entire module here is made out of pieces of aluminum. And our screws here, we have some little rings here to keep the screws from coming out and getting lost. Looks like this cover here can come off with the removal of these 2 screws on the top. Underneath we have some gears and a nice little dial here. Now with the long pink screws removed, let's take off this cover here. Here's what we have underneath. You can see the main dial here. We have some more gears, and we have a micro switch here and here, made by the company Micro USA. Now let's take a look what's underneath the other side. Alright, so here's what we have on the inside. We have a lot going on in here. A cool detail is that these components inside here are actually labeled here on these metal covers. This yellow piece here seems to be some kind of electric motor. These 2 identical devices are called synchros, which are an electromechanical device that converts the angular position of a shaft into an electrical signal. These 2 are made by a company called Singer. These last 3 devices are also synchros. You can see this one here is made by Dale Electronics, and this one is really interesting because this one is serial number 1. The other one down here is serial number 3566. So that is pretty cool. We also have another one here. This one is obviously a different type or different brand. Another awesome detail is that this entire metal piece here that extends all the way throughout this is a single block of aluminum. It has been milled out. If I rotate this gear here, you'll notice that the middle gear only has 2 teeth on it. So it only engages this shaft, which goes to this synchro, once every time this goes around. Rotating the same gear, we also have movement down here. As you can see, this funny shaped gear here has a little notch in it, which activates this little micro switch here when it rolls over the notch. Just like that. This other notch here can be adjusted with a screw, so that's probably for tuning or timing purposes. We also have a second one over here. Something interesting that I've noticed while working on this is that all the hardware in here is non-magnetic. So I have a strong magnet here. You can see nothing is picked up. So there must be a reason for that. I'm not exactly sure why. Okay, let's take a look at the next section back, which is underneath this cover here. I'm guessing this piece of metal here is for protecting the boards underneath. So we can just pull this up and off, revealing the boards. You can see each board here is color-coded. We have board A7, board A6, A3, A5, and A4. To remove this first board, we need to gently pry it up. This board here is the electronic control servo amplifier board. On the top here you can see we have 11 test points. The inner contacts are gold plated, and on the bottom we have the D-sub connector for connecting it to the rest of the assembly. As you can see, they're using Teflon wire here, which is used in most avionics. You can see on this board we have a lot of carbon resistors, transistors, and some glass body diodes like this one here. All the transistors on this board are socketed in these little turquoise sockets. As you can see, you can take one out if you need to, and you can put it back in. Up here we have this self-test section. You can see it's divided off with these black lines. It also contains this silver mica capacitor. Here we have a Motorola power diode and a smaller gold-plated one down here. We also have a 2N3055 MPN power transistor here. This board also has this small little potted module encased in metal. As you can see from this side, it does have a Collins logo on it. Over here we have another potted component. This one is a transformer. As you can see, it's manufactured by ADC. Here's the back of the board. Up here we have an adjustable trimmer made by Boeing. The rest of the backside is mostly passive components, with the exception of these two gold-plated transistors up here. Here's our next board. This one is the search track switch board. As you can see, it is constructed similarly to the other board. We have some bigger capacitors on this board too, made by a company called Sprague. We also have lots of transistors and passive components. We have two power resistors here, and what looks to be an op-amp up here. Here's the back. We have some silver mica capacitors here, and we also have a ceramic disc capacitor. Down here we have another gold-plated Motorola diode. Here's the next board. This one is the pulse distance decoder board. As you can see, this board has a lot of transistors and a few small silver mica capacitors. These brown resistors here are metal film resistors. Next to them we have two little gold-plated diodes. Down here we have some bigger capacitors. These ones are made by Tanalex. In the middle of the board we have a small potted transformer, and we have another transformer over here which is not potted. This box here, branded by Collins, is some kind of filter. On the back we have more of the usual stuff with similar components to the front. On the top here we have two blue trim pots and three red ones made by IRC. Here's the second to last board. This one is the distance interrogation generator. In the center here we have two power diodes and some larger capacitors which are mounted in these little holders here. We have quite a few silver mica caps, including this big one up here. We also have a few of these turquoise resistors, like this one here and this one here. Here is the back. We have three trim pots at the top, and we have some more silver mica capacitors. We have some capacitors over here which are pretty long and thin. We also have some more of those nice little turquoise resistors, and we have a single ceramic capacitor here. Here's the final board. This one is the distance time-based generator board. We have several more of these little Collins potted modules scattered throughout this board. In the center here we have a Collins branded inductor, which is potted in this black epoxy. We also have more silver mica capacitors, like these two here. We have a few more power resistors, which are inside these little pieces of tubing. We have a few big turquoise resistors and a few smaller ones. In the bottom here we have a large crystal oscillator, and next to it we have a Collins branded filter. Here's the back of the board. We have 5 trim pots up at the top, and some more of those long capacitors, and everything else is pretty much what we've been seeing. Alright, now back to the main assembly. To take this apart anymore, we have to remove these aluminum side panels. This side panel here is made out of sheet aluminum, and to remove it we need to take out all these screws over here, these screws, and all these screws over here. Both side panels are folded down over the edge here, so we have to take out these screws up here and these screws down here. On the front here I will have to take off these 4 screws here holding on these clips, these 2 screws here, and these 4 screws here. On the back I will have to take out these 2 screws and these 2 over here. Okay, now that we have those 2 sides removed, let's take a closer look at this section here. You can see our D-sub connectors. We have one larger one, and the rest are smaller ones. We have these pins here that are in different spots for every board, and the corresponding board has a hole in a spot which lines up, allowing only the correct board to fit into that slot. These are the 2 aluminum pieces which have grooves in these plastic pieces for aligning the boards. This one here was mounted here, and this one here was mounted here. These plastic pieces here are riveted in place. We also have threaded steel inserts for the screws. All the other pieces of sheet aluminum also have threaded inserts. Here's the little piece that the distance mechanism sits on. Here's the wiring behind it. You can see they are using zip ties here. That's not original. All the wiring here originally used wire lacing. We can also see the wires for the test button here, and these 2 little wires coming off the other 2 little coax connectors. It's kind of a surprise to me that I'm not seeing a coax here. The next step in our teardown process is to take this whole transmitter and receiver section off. You can see we have some pretty substantial screws down here which connect to this whole assembly into this frame here. We also have 3 of them on the other side. I'm going to set this aside for a little bit and we'll take a closer look at the rest of the assembly first. Here's what it looks like now that that assembly has been removed. It is labeled as the radio receiver transmitter. We have a big coax connector here and a D-sub connector. Over here is the label for this entire assembly. This is the chassis power supply assembly. We have 3 transformers. It looks like 2 of them are labeled manufactured by ADC. I'm sure this one is too. Maybe the label's on the other side. We have 2 stacked boards here, which look like they come out with these 2 red screws. Okay, here it is. You can see this has 2 stacked little boards and a D-sub connector to connect it to the rest of the assembly. We have 2 potted Collins modules. Both of them are labeled EPC module. I'm not sure what that means. We also have 2 capacitors here and 2 capacitors here and some passive components. Okay, now that I have taken out the 2 non-painted screws, we can see the inside. We have 2 more EPC modules and some wiring to connect the 2 boards together. On the underside of the top board we have 2 diodes and some wiring here to connect them together. Now we can get a closer look at this wiring here. You can see we have some wiring that goes down through this metal piece in the chassis here, through a grommet. We have the wiring running through this little piece of plastic tubing, probably to keep it protected. Down here we have our fan. This one is the Aximax 2X, made by a company called Rotron. This fan is rated 22,750 RPM. On the top here you can see these aren't actually fan blades, but these are stator vanes. The actual rotating part is under here, as you can see, and it's on some pretty smooth bearings. It'll rotate a while. Looks like we have a few grounding points here. We've got 3 of them. They're just connected to the chassis here. On the back here you can see we have the 3 transformers labeled, T1, T2, and T3. And this is the EPC assembly. It looks like we have some more components behind this piece here where the connectors are. Okay, so here's what we have underneath. You can see the main harness here going to the connectors. It goes along here, and some of it goes back here, and some of it goes back here. Here we have these 2 modules. These are radio noise filters made by a company called Cornell Dubilier. Here we have these 2 capacitors mounted on this little metal plate here. On the other side we have another radio noise filter that is identical to the other 2. And we also have another little capacitor under here. Back here you will also see this aluminum piece here, which is screwed down. This is a structural piece to support this area back here. It is screwed down from up here, and it sort of bridges the gap between this metal and the bottom of the unit. Let's take a look at this section here, which is the more substantial part of this power supply. Okay, so back here is the connectors we looked at and the fan that we saw earlier. Right in the center here we have a fuse. It is mounted on this like epoxy board piece, which is then mounted on this aluminum piece here. On both sides here we have what seem to be some kind of structural pass-through. As you can see, the wiring is soldered to the posts, and I'm guessing the wiring that is coming out here and going back here is soldered to the other side of the post inside this piece here. This piece is also an anchor point for the side panels that we took off at the beginning of this video. And you can see that this is screwed on with these screws here. We have some back here, and then there's a little edge down under here which also has screws in it. And same thing for this other one up here. Over here we have a pretty big capacitor and a turquoise resistor to the left of it. Down here is the bottom side of the connector for the main antenna wire. As you can see, it goes through the aluminum frame and comes out right here, and that connects to the transmitter and receiver section. As you can see here, we have 2 holes for access points to trimmers that are mounted inside the transmitter and receiver section. This one is for the power amplifier tube trim. Up here we have something interesting. We have this turquoise socket here, which has this little circuit board piece in it, which contains pins that are connected together, and I'm not sure exactly what this is. Maybe it's for configuration. It's also possible that this is some kind of placeholder for a part that isn't used in this unit. Maybe that's why we have these 2 spots for screws here. Over here we have this big gray module. This is either a transformer or some kind of delay network. Below it we have another fuse. You can kind of see it down there. It's mounted in a little plastic holder. We also have this little transformer up here. We have another big capacitor here and a smaller one beneath it. We have this little piece of metal here which has 3 power transistors mounted on it. We also have another capacitor down here and another one over here. Here's what we have beneath that stuff. We have the connector here, which goes to the transmitter and receiver section of this unit. Right here we have 2 big capacitors. You can see that they are mounted to this frame here with these metal pieces. They are riveted on, and this has been ground smooth. Over here we have another fuse block. This one has 2 fuses in it, and it is screwed onto the frame. We also have another little capacitor which is hiding down here. Right here we have a ground point and a wire wound resistor. Beneath that we also have another little capacitor. On the side here we have what looks like a test point, but this is actually a ground. As you can see, it is labeled right here on the side panel. This is probably to ground it while it's being serviced. The next portion of this area contains the 5 D-sub connectors for those boards that we took a look at. Over here is the last section of the main antenna. This is a low pass filter. This one has a cutoff frequency of 1220 megahertz. As you can see, the logo here is a blue circle with a little flying dove in it, and it looks like we have some like lightning bolts or something around it. And as you can see here, this is made by Bird Electronics Corp. You can see here we have a big delay network. We also have the wiring harness here, which goes underneath this low pass filter and through the metal frame here and through a grommet. This is the harness which goes to this connector here. Now let's take a look at this board in the center, which we haven't looked at yet. You can see we have a whole bunch of transistors here, kind of clustered together. We have some trim pots here. We got 3 of them. Over here we have a section of passive components which are mounted at an angle. You can see we also have more of those turquoise resistors. We have a little glass body diode in there too. And it looks like they extend all the way over here. Here's the last section of the middle board. It looks like we have some more capacitors over here. And we have another one of those little gold-plated Motorola diodes. So let's move on to the really interesting stuff, which is the transmitter and receiver section. Let's take a moment to look around this piece first before we start taking anything apart. You'll also notice that all these metal pieces here have this pink color to them. That's because all this metal is silver plated, and over time it's taken on a pink appearance. So all this metal is probably solid copper or brass. We have this module here and these 2 modules, and over here we have some mechanical stuff. Let's first take off this module here. This module is the pulse modulator module. Okay, here it is. You can see we have some kind of circuit board material piece here. I'm not sure what the purpose of that is. You can see the wiring going to this D-sub connector here on the other side. We have a few transistors here, along with a few passive components. We have these screw-on plastic pieces which go onto these power diodes. We have one of those skinny long capacitors here and another one here. It looks like we have a resistor here. You can see we have these 2 really large Sprague capacitors. These are from a product line called Vitamin Q. They're supposed to be specifically formulated capacitors, and these are actually mounted onto this metal piece here. Down here we have 2 inductors. You can see they've had to mold this aluminum piece here to accommodate the size of those. Just like the 2 capacitors, they are mounted on this little aluminum piece here. We have the bottom side of those 2 power diodes. We have a few other components in here. We have some big black diodes. We have a silver mica capacitor. This is interesting. It says to torque the nuts between 10 and 15 inch-pounds. Alright, let's take a look at our next module. This module here is the frequency multiplier amplifier. Up at the top here we have a coaxial connection which is not being used, so it's capped off. And you can see the little cap here is held onto the main chassis here with a little chain. We also have another coaxial connector here, and we have 2 more over here. Right here we have some kind of rotational coupling which connects to this module. Over here we also have another mechanical connection to this module. You can see this piece back here. This piece can move up and down. To remove these coaxial connections, we have to rotate this little piece here, and it unscrews and allows us to undo these connections. To get this module off, we have to pull up this side first, and we have to slowly loosen it up. Here's the one side of the rotational coupling. You can see we have 3 raised bits here. Those correspond with this receiver part here, which has spaces for those little pieces to slot into. For this other mechanism here, we have this metal piece which has a hole in it. This corresponds with this metal peg over here. On the top here, there's an interesting note. It says position unit to channel 1 before removing. Here's what we have on the inside. You can see here this rotational piece goes to this variable air gap capacitor. You can see that we have these different plates, and this changes the capacitance, and this is probably for tuning purposes. You can see that we have 2 stationary plates and 3 that move. Some of them are a different distance away from the stationary plates. You can see each capacitor is part of one of these 4 little compartments here that look like they have identical components. Maybe each one is for a different channel or frequency. Down inside you can see we have an inductor. We have some resistors that go between them. You can see there's a little hole in the metal here to let the resistor through. We also have these other little components that I think are resistors. You can see that they are brown and they have some green on the edge. We also have these trimmable components. I'm not exactly sure what they are. I can't really see the part number too well. This RF connection here goes to that one little component and a silver mica capacitor down in there. In this other compartment here we have 2 variable capacitors. We have a transistor, a few other capacitors, and a resistor. Moving up here we have the connector. We also have these interesting little pass-throughs here through this metal. Right here we have a transistor, resistor, and some caps. In this one here we have 4 variable capacitors. We have a big resistor and what looks like another transistor. Over here we have an inductor. What's interesting though is we have a little piece of wire that's connected to the second loop of it. We also have this really nice gold-plated and white ceramic RF transistor made by Motorola. It also looks like we have another one right here with these 2 capacitors. Here's the last section. We have more variable capacitors here and some more of those RF transistors. You can also see here we have these 2 RF power diodes. They are also in gold-plated metal and ceramic. You can see we also have these weird little flat black components at the bottom. I believe these are capacitive pass-throughs. We have another one over here and one more here. Here's that RF connection that isn't used. It goes to this one little resistor here and connects to this variable capacitor. Next I want to investigate this piece here. Let's take out these 5 screws and see if there's anything interesting under there. These 2 RF connections just come off like this. You can see they are connected together in an interesting way. I'm guessing here this is some kind of small resonance cavity. It's hard to see this on camera, but on the end of this metal rod here we have a plunger, it looks like, that is the circumference of the inner diameter of this piece here. So that will adjust the resonant frequency of this cavity. I've also taken out the screws to this little top piece here, and this comes off like this, revealing a really interesting component here. I'm not exactly sure what this is. We also have this little metal piece here. It looks like it provides additional support to this component. Inside here you can see there are 3 little legs which go to this component. The 2 go to the 2 contacts on the top, and then there's a single one on the bottom which goes to this metal little clasp here, and it goes and makes contact with the middle portion of this component. Back here you can see we have another cover, and it's got some screws, so let's see what's underneath. Here's what we have underneath. You can see we have lots of resistors and capacitors. I believe these are resistors here. They are capable of handling higher currents. We have some more capacitors and resistors around here. We even have some components up here. And there's like a little channel here for the wires to get through. You can see the nuts here, which hold on the high frequency transistors and diodes that are on the other side. It does appear like this whole entire piece here is a machined block of brass that has been silver plated. This piece here is separate. You can see it's screwed on here with some screws. You can see we have these little metal pegs here which help line up the cover. Okay, back to the main assembly. Next I want to take off this module here. This one is the intermediate frequency amplifier. To take it off we have to take out these 4 screws and remove this coax connector. Alright, here it is. Here's our connector for connecting it to the rest of the assembly. And here's the back side. And we have a test point here. We have some more test points and some spots here for making adjustments to trimmers. Here's what we have underneath the top cover. You can see immediately we have these 2 big gold-plated filter boxes, and we also have another one here. You can see our input and output is labeled, and it is screwed on with these little nuts here. Our coax connection is connected to this little box here. You can see we have a few different capacitors, and it looks like we have a component in there that has some wire wrapped around it, maybe for an inductor. In the next compartment we have 2 silver mica capacitors, and we have a big resistor down there and some more capacitors. And right here by the side of the filter we have a capacitor, and it looks like the backside of a transistor socket. We also have one over here. It looks like we also have similar components in these 2 compartments. You can see that we have some pass-throughs here. We also have some over here and here. Alright, here's what we have in the biggest compartment. You can see we have some socketed transistors. We also have a few of these adjustable capacitors. In the last part here we have a single transistor and a few resistors. We also have a few capacitors. On the back side we also have another cover, so let's see what's underneath. Here's what we got. As you can see, this part has a lot of similar components to the other side. We have the transistors here, which we saw the sockets for on the other side. Over here we have a crystal oscillator, which is mounted in this little metal bracket here. For some reason these 3 sockets here are black instead of turquoise like all the rest of them. Here's the back side of those test points. You can see it's on this little metal bracket that is screwed into this main metal piece. At the top here we have some more trimmable capacitors which are mounted on the side so they can be adjusted. We have 2 more over here. Just like the other module we looked at, this is machined out of a single block of brass and silver plated, which is probably quite expensive, I would imagine. Alright, now back to the main assembly. It looks like the next piece to come off is this pre-selector unit here. It looks like we have a screw here holding it on. We have some screws here on the sides. And we have some kind of rigid coax piece to remove. We also have a mechanical coupling, which is on the back side of this unit, which connects to this moving piece here. Okay, so here it is. On the bottom here we have our main connector, which goes to the main antenna. Here's the rigid piece of coax. To take this out I had to remove this little hex key on this little clamp here. So my guess is that this rigid coax here delivers the amplified high frequency signal to the pre-selector, and this is our output for the main antenna, and we have 2 other coax connections for something else. Immediately I can tell that this is going to be some kind of 3-chamber cavity. You can see that these pistons here are going to be moving up and down to tune the resonance frequency of each of these cavities here. On the back here is our mechanical coupling, which connects to this coupling here over in this mechanical section. On the back here we have this movable arm here, which is connected to these 3 pistons. It is spring loaded. As you can see we have a big spring back here. If I move this arm up, you can see here that our mechanical coupling here connects to this funny shaped piece of brass. You can see it has notches in it, and we have a roller bearing on this arm here which sits on this piece of brass. So when this piece here is rotated, this roller bearing rides on this piece here, and it will sit in these notches for different tuning pre-selections. You can see there's another one right here. You can see here on the center cavity, this one is labeled channel 1. So maybe this one is like channel 1, channel 2, and channel 3, or something like that. I'm not sure. We also have some interesting labeling here on this piece here, which goes to this coax piece. Maybe this piece can be mounted a certain distance into this block here for further tuning purposes. To confirm that, let's take this little cover off here and see what's underneath. Okay, so taking out those 4 screws has actually taken this whole piece off. So let's take a closer look at this. You can see here that we have a diode marking on this cover here, and we have a high frequency diode in there. Here's what we have on the back. You can see this is like an antenna. So the radio frequency signal is going to be radiating off this antenna here, and it's going to radiate inside of this cavity here, which is tunable by these 3 pistons here. I've also taken out the screws for this metal cover here, which you can see it just reveals a solder point in there for this wire here. You'll also notice the machining marks in this block here. This piece here is also machined, as well as our main pre-selector unit here. Next, I want to take off this cover here, which is held on with 8 screws. Now with the cover removed, we can take a better look at these cavities and the tuning rods inside. You can see here when I move the metal arm, these rods move inside these other metal pieces. Each of the 3 cavities is connected by opening up here. You can see that this opening goes all the way through. You can also see over here we have another one of those little antenna pieces like we saw on this piece here. It is all the way at the top of this. You can see in there, and I believe that goes to this connection here to this rigid coax. Okay, back to the main assembly. The next thing I want to look at is the electromechanical section. That is basically everything from this point and to the right. To remove this section, I have to take out these 2 screws here and this screw here. We also have to take out this 4th screw here. Now that I have pulled this away, we can see we have another mechanical coupling. This one is the bottommost one, which connects to this end here. As you can see, it's still attached by this wiring harness here. Unfortunately, there's no connector, so we're just going to have to work on it carefully. This section is labeled the channel selector. That is because it contains the mechanics for moving the various tunable components to select a frequency or channel to operate on. Here's a look at the wiring harness. You can see we have some wires going into this section here. We have a piece of coax coming out from this harness as well. We have some more wiring going into this module here, and the rest of it wraps around here to the other side. You can see we also have another coax wire here, and the rest of the wiring is connected to this toroidal transformer, which is screwed onto this metal piece. We also have a singular diode here. You can see the one side is connected to ground along with 2 other wires. Looks like we have 3 wires going underneath this little cover here, so let's take out these 2 screws and see what's underneath. Here's a little metal cover. As you can see, the screws are attached in a way that allows them to stay in place. They cannot fall out. This is common with all the screws on this unit, which are painted in this purpley color. Here's what's underneath that cover. As you can see here, we have a larger gear and a smaller gear. It looks like this probably goes to a motor on the other side. We also have a set of wafer switches here. This part in the center will rotate and make connections to various contact points around this piece. It looks like here we've got the backside of another motor or a synchro. The next cover I want to remove is this one here. It's held on by 4 screws. Here's what we have on the inside. You can see we have some gears and shafts which are connected to these mechanical couplings here. We also have what looks like the other side of a motor, but to get a closer look at it, we're going to have to take this cover off here. Here's that motor. It has a Collins part number on it. It also says Globe Industries, division of TRW Inc., made in Dayton, Ohio. As you can see here, our wafer switch is connected to the gearing for these mechanical couplings. This is so the circuitry in here knows what position it's in. Down here we have this little contact switch. You can see that the movement of these gears will close this gap, which makes continuity. It is connected to the wiring here, which goes back in here. We also have a resistor here and what looks like a little diode and a grounding post. We have one more cover here, so let's take it off. Here's what we have underneath. We have another toroidal transformer, and we have a gear and another shaft here. This one looks like it goes into this box here. We can also see inside here we have this circular piece down here. You can also see it from this side. I'm not exactly sure what that is. Maybe it's some kind of a clutch mechanism or some other mechanical thing. I'm not sure. Moving on to the next cover, we have this one here. We have two screws and it looks like it is slotted underneath these two metal pegs. Here's what's underneath. You can see here this is the shaft coming from the little DC motor. You can see we have a pretty big gear ratio here, which is necessary to turn all the mechanical pieces in this piece of equipment. You'll also notice here that these shafts have their own little bearings. This is true for all the mechanical pieces in this equipment. Here's the last side. You can see here the aluminum casting which makes up this whole gearbox. We also have a gear here which is sticking out a little bit. I guess they didn't have enough room inside for it. Alright, the next thing to look at is this module here. You can see this is a aluminum box here. It has a lot of screws holding it on, and we have two little windows on the front here. You can see we have numbers in there. We got 10 and 7. So apparently those are the channels. Here's what we have inside. As you can see, we have a lot going on inside here. First, let's take a look at this board here. Here it is. You can see we have some trimmable capacitors along the top. You have a few transistors here and some silver mica capacitors, as well as some other components. It looks like this nice gold-plated component here is a transformer. You can see it's marked T4 on the silk screen here, so that must be a transformer. Looks like we have a resistor here capable of some higher power. Okay, here's the back. You can see we have several resistors back here and a few other components. We also have some coax wires. We have a brown one here and we have two of these white ones. This wiring goes through this piece of circuit board-like material. On the other side here we have another board. This one is populated with similar components. The printing on this cover here seems to suggest that these are resistors. You can see these components are 1% tolerance, and these are likely military spec parts. These are made by a company called RCL. Alright, here's the back side of the board. You can see the wiring here. These components are mounted on these little Teflon and gold-plated standoffs, just like all the other components in this machine. Alright, so here's what we have in the center. You can see we have two shafts here and some gears connecting them together. We also have these number dials here. The rest of this area is taken up by these wafer switches. When this piece here moves, these contacts will meet up with these exposed metal pads on these PCBs, and it will make and break connections. I believe these are the master oscillators. Each one is a different frequency, and the correct one is selected for the desired channel, and the other mechanical pieces move into the correct position. The next thing I want to do is take off this piece here. This is one continuous piece. You can see we have a high voltage power supply here. It also extends over here, and we have plenty of screws to take out. On the other side here, we also have this electronics module, which is riveted into this piece. You can see here the circles where the rivets were flattened down. To remove this section, we have to begin by taking off this bracket here. We have 8 screws on this side and 1 screw here. The next screws that need to come out are these 4 purple screws here on this module. Okay, so I've been able to pull this piece off a little bit. First, let's take a look at what we have over here. Here's the backside of the high voltage transformer. This is the transformer which provides the high voltage for the planar triodes. On this side over here, we have a large resistor. We have another smaller one here. Back here, it looks like we have a diode and some other wiring. Here's the output side of the transformer. You can see we have a resistor and a diode underneath. We also have the 4 wires which go to the 4 planar triodes. We have a black one, a red one, an orange one, and a yellow one. These wires are then routed along here, and they break out to each of the 4 triodes. Alright, here's the next board to look at. This one is called the PO channel selector subassembly. In the middle here we have a power transistor, and we have some other transistors here as well. We also have a power resistor over here with some smaller power diodes. These ones are also the gold-plated ones from Motorola. We have 3 of them, 2 here and 1 down here. All the rest of the components on here are pretty much passive components. We have a lot of these little glass-bodied diodes. We also have these 5 openings here for adjustments. These 2 over here are the power amplifier slope adjust, as well as this one. In the center here we have a incline slope adjust. These holes here allow access to these Allen key points here. These are for adjustments here which adjust the mechanical assembly back behind here. Now we can take a look at what's behind it. As you can see, we have a lot of point-to-point wiring and a whole row of these ground points. Our harness coming from our mechanical section also goes over here. We have a few other components back behind here, mostly passive components. Over here we have a transformer box. You can see it is held in place with these nuts, and here are the connections. It's just about impossible to get this transformer out, but you can see here the label. We have a transformer schematic symbol here, and this one is also manufactured by ADC. Next, I would like to take a look at the core of this machine, which are these 4 metal chambers here. Each one of these chambers contain an RF planar triode. The triodes are in these thick silver-plated brass chambers to provide heat dissipation, shielding, and a sturdy structure. On this side you can see we have these 3 tubes. These are what house the high voltage wires going to each of the triodes. On the other side we just have 1, so that's 4 in total. It looks like you can gain access to the inside of these tubes and the wire inside if you take out these little snap rings and this little cover that's on top. You can also see we have 2 test points here and 2 more over here. These test points go to these green wires, which go to the bottom of these chambers here. On the top of each chamber you can see that we have this little handle here and this little lid. You can actually pull this off to reveal the triode underneath. You can see this piece here is machined metal, and we have these little spring contacts which are soldered on to make contact to the inner wall of this chamber here. And here's our triode inside, and our little high voltage wire which comes from the tube piece and goes in there. Here's one of our 4 triodes. This is the anemic 7815R planar triode. Each one of these is capable of 100 watts peak, so we have 4 of them, so 400 watts peak output, which is pretty substantial. We also have this kind of wavy spring contact. It's on top of this circular piece of circuit board material. Next, I'm going to try to take out this tube so we can take a closer look at it. Alright, here's our tube. You can see this one is a very nice one with white ceramic and silver contacts. On the top we have our fin stack for cooling purposes. This topmost contact here is our anode. That's where the high voltage is supplied to the tube. We have our grid and our heater. Here's what the inside of our chamber looks like. You can see we have a series of spring contacts. Our high voltage wire there connects to the top row of spring contacts for supplying high voltage. Moving on, the next thing to look at is the mechanical assemblies below these cavities here. First, you can see here we have this mechanical coupling. It's similar to the others. It connects to this bottom one right here on this mechanical assembly. Similar to the pre-selector, this has this little piece of metal back behind here, which is not quite circular. And we have this roller bearing here, which is connected to this arm, which is connected to a shaft that goes back there. So when this moves here, this roller bearing rides along this metal piece and it moves this whole entire assembly here. You can see the shaft extend over here. We've got these two thick metal pieces which contain bearings for the shaft. Here's a look at the opposite side. The shaft is back here. You can see we have these posts attached to the shaft. So when the shaft moves, it presses down on these mechanisms here. When this mechanism here is moved, the two tuning rods going into this cavity also move. So this means that these chambers up here are not only just a containment device for the triode, they are also resonant cavities as well. Something else that's quite interesting that I noticed is that these tuning rods seem to be made out of a different kind of material. You can see this material here is this yellow, kind of semi-transparent material. And this one is this sort of white material here. And the one that's on the other side of this one is the tan yellow material. And the one that's on the other side of this one is the white material. You can also see we have these little adjustment points here to fine-tune the actual movement of these pieces. On the bottom here we have these metal plates. We also have a wire connecting to each of these chambers. And we have what looks like a small little cover here as well. I'm not sure what's in these cylinder pieces here, but it looks like it would be too difficult to get it to come apart. You can see that we have tons of screws holding it onto the base of this big metal structure here. It looks like these metal pieces here can be taken off, so let's see if there's anything interesting under. Alright, here's what's underneath. You can see we have our wire going into the center. We have 4 more screws here. And you can see that this piece here is all machined metal. Now I also noticed we have a really thin piece of rigid coax down back here that goes along this metal cylinder here. It's kind of hard to see, but it comes from up here. It goes along the edge here, and it goes into this little piece here. So I am guessing this is where it is terminated, is underneath this little metal piece here. On this other one here, you can see this piece of rigid coax comes from the top of the chamber, goes down here, and then it makes a right turn, and it actually goes all the way around this piece here, and then it's terminated into this little piece, which is interesting because this is the only one which does that. For this final cavity here, you can see it's not terminated to a rigid piece of coax, it's terminated to a regular piece of coax here. This piece of coax goes behind here, and it comes out here, and goes to this connector here. So that's about everything there is to see for this mechanical section, and this of course concludes the teardown of this DME. If you've made it this far in this video, I greatly appreciate it, and that's it for now. See you next time.